Welcome student. Today we are going to study types of crystalline solids. In first lesson chemistry part 1 standard 12 first lesson solid state, and in solid state we have studied further. We have studied that types of solids, that are crystalline solids and amorphous solids. What are properties of crystalline solids and what are properties of amorphous solids, that we have studied. Now we will move towards classification of crystalline solid. Further classification of crystalline solid. In classification of crystalline solid, the basis is the type of intermolecular force or type of force of attraction between atoms or molecules of crystal. Crystalline solids are in a form of different types, like organic substances are crystalline. Some inorganic salts are also crystalline in nature. Then metallic substances or metals and non-metals are also in crystalline state. Therefore, classification or study of crystalline solid is important. In this video, we will going to study classification of crystalline solid depending on force of attraction between atoms or molecules of crystal. Now, depending on this basis, there are 4 types of crystalline solids. In that, first one is molecular solid, second one is ionic solid, third one is metallic solid, and fourth one is covalent solids. We will study first one, molecular solids. Pay attention. Here you can see molecular solids has 3 types: polar molecular solids, non-polar molecular solids, and hydrogen bonded molecular solids. Now, if we study comparatively, in case of molecular solids, the constituent atoms or constituent particles in molecular solids are molecule of compound. In ionic solid, the constituent particles are ions of solid. There may be anion and cation, both. In metallic solid, atoms of metals are constituent particles of metallic solid. And in covalent solids, atoms are constituent particles. Now, we will study first molecular solids. Now, the information of molecule that you know first, that molecular solids are present in molecules of same or different compounds. Force of attraction between molecules here in molecular solids are of 3 types, and depending on that, molecular solids are further classified as polar molecular solids, non-polar molecular solids, and hydrogen bonded molecular solids. Now, in a particular molecular solid, if bonding between constituent atoms of a molecule is polar, that means there is separation of positive and negative charge, as like HCl. In HCl, hydrogen has partial positive charge and chlorine has partial negative charge, and this is due to electronegativity difference between constituent atoms of a molecule. Such a charge separation between molecules is called as a polarity, and due to this polarity, that molecule will become, or intermolecular force of attraction is polar, or polar molecular solid. Now, in polar molecular solids, the crystals are generally, or nature of solid is soft. It is generally soft in nature. It is a poor conductor or bad conductor of electricity. It don't conduct electricity at all. The force of attraction is positive and negative charge. Okay. Now we will move towards non-polar or molecular solid. You can also call it as weakly polar molecular solid. Now in non-polar molecular solids, there is no any charge separation because atoms of constituent molecules don't have electronegativity difference. There is no large electronegativity difference between atoms of constituent molecule. Here, as there is no charge separation, they are called as a weakly polar or non-polar molecular solids. Generally, non-metal gases damage non-metals like Cl2, H2. These are the examples of non-polar molecular solid. Polar molecular solids, as they are soft, the melting point of that solid is very weak. And melting point of non-polar molecular solids is also very weak. They are also soft. Both polar and non-polar molecular solids are soft in nature and both have low melting point. As they are soft, more energy is not required to breaking the bonds. Therefore, both they have low melting point. Now, third type of molecular solid is hydrogen bonded molecular solid. Now, what is meant by hydrogen bonding? When consider example of water molecule. When you are considering two water molecules, when a hydrogen atom is bonded to more electronegative atoms like fluorine, oxygen, nitrogen, etc. and it will form additional bond. In a crystal, if hydrogen bond is bonded to more electronegative atom and if it forms additional bond with more electronegative atom, the additional bond formed by hydrogen atom is called hydrogen bonding. Example of hydrogen bonding is present, or example of hydrogen bonding you can see in water molecules. Consider two water molecules. Now, in first molecule of water, hydrogen is two hydrogens are attached to single oxygen. Now, hydrogen of this molecule is able to form bond with oxygen of second molecule, and this bond is additional bond. Therefore, this bond is called as a hydrogen bonding. As like water molecules, another examples of hydrogen bonded molecular solids is ammonia, alcohol. Now we will see structure of this hydrogen bond. Consider this is first molecule of water and this one is second molecule of water. Here you can observe hydrogen can form only as valency of hydrogen is 1. It will form only one bond. Now this oxygen is electronegative. There is a formation of bond between this oxygen and this hydrogen. Due to this additional bond, hydrogen will acquire partial positive charge originally and this will acquire partial negative charge, and this bond is called as hydrogen bond because electronegativity difference between hydrogen and oxygen is very large. This will be polar in nature. You will observe two charges here, positive and negative charges. Okay. Now we will move towards ionic solids. Ionic solids. In ionic solids, constituents particles are ions of particular atom or ions of salt. Consider example of NaCl. Here Na plus is cation and Cl minus is anion. Here in ionic solids, sizes of anion are generally bigger than sizes of cation. They may be similar, but in most of the cases, sizes of anions are greater than sizes of cations. In ionic solids, if we see characteristic of ionic solids, then ionic solids are generally hard in nature, as bonding between cation and anion. Cation has positive charge, anion has negative charge. The force of attraction between oppositely charged is called electrostatic force of attraction. This will compensate the charges or neutralize the charges on cation and anion. And due to this, bonding between these ions or ionic solids is very strong. As this bonding is very strong, the crystal form is generally hard and melting point of crystal is very high. Now, in ionic solids, they are bad conductor of electricity and when they are in solid form. But as they will get fused or they will mix with water or in aqueous solution or in fused state, ionic solids are good conductor of electricity. What is reason behind this? The reason is that in solid state there is no any charge carrier. To conduct electricity, charge carriers are required. In solid state of ionic solid, there is no any charge carriers. But as ionic solids are getting converted to fused state, means they are melted, or in their aqueous solutions, the ions, that means cations or anions, will be free. And as they will become free, they will mobile. They will move from here to there. And they will carry, they have charge, no? They will carry charges with them. That means they conduct electricity. Therefore, in solid state, ionic solids are bad conductor of electricity, but in their fused or aqueous state, they are good conductor of electricity. These are four properties of ionic solid. First one, bonding between cation and anion is strong, or electrostatic force of attraction is ionic or electrovalent. Second point, as bonding is very strong, they are hard in nature, hard and rigid. As they are hard or bonding between them is very strong, their melting point is also very high. And last one, in their solid state, ionic solids are bad conductor of electricity, but in their fused or aqueous state, they will conduct electricity. Now we will move towards third types, metallic solid. Metallic solids. In metallic solid, constituent particles are atoms of metal or atoms of metallic elements. As we know that metals are good conductor of electricity, here charge carriers are electron. Now, if you consider a sheet of metal, then metal's cation will give electron, or metals will give electron and convert it to metal's cation, and these electrons are not holding or restricted to one region in that metal sheet. That electrons will move throughout the sheet, and due to this, metallic solids are considered as, metal cations are considered as a kernel and electrons are considered as a seed. And as electrons can move throughout the sheet or throughout the solids, metals are good conductor of electricity because charge carriers are electrons. Bonding between this moving electron or mobile electron and cations of metal This bond is metallic bond. This bond is strongest of all types of bond. It is stronger than molecular bonding, ionic bonding or covalent bonding. As this bond is very strong, melting point of metallic solids is also very high. As electrons are charge carriers, they are good conductor of electricity. Other properties of metallic solids are ductile. Metallic solids can be they show property of ductility, means they can be drawn into thin wires. Other properties of metals are also applied to metallic solids. Other property is malleability. They can be hammered to form thin sheet. Okay, these are the specialty of metallic solids. They are hardest known material. Metals are hardest known. Diamond is the hardest known material. Now diamond is made up of carbon, but carbon is not metal. Then how it will be? Question is how diamond is made up of carbon and carbon is not metal, and we know that metallic solids are hard and rigid. Bonding is very strong. Then how is this possible? The answer is covalent solids or covalent bonding. In covalent solids, the bonding between constituent particles or constituent atoms is covalent. Now, generally covalent bonding is formed between atoms of elements of same electronegativity or similar electronegativity. When electronegativity difference is small or no electronegativity difference, then covalent solid will be formed between atoms of such elements. Now in covalent solids, as I say, bonding is covalent. Bonding between atoms is covalent in nature, and also bonding will network like solid. In covalent solids, atom will combine with neighboring atoms and the result is network of solid will form. A huge network of solid will form. This bonding is also very strong, and therefore covalent solids are hardest. Therefore, in diamond three-dimensional network structure you can observe, because in diamond bonding between carbon-carbon neighboring carbon atoms is covalent bonding. Covalent solids are generally bad conductor of electricity, but graphite is example of covalent solid which is a good conductor of electricity. All the allotropes of carbon are examples of covalent solids. These are also rigid, they have high melting point, they are non-conductor of electricity or bad conductor of electricity. Now we will move towards summary. I will repeat. Covalent crystalline solids are classified on the basis of force of attraction between atoms or molecules of crystals, and depending on this, covalent crystalline solids are classified into 4 types. In that, first one is molecular solids, second is ionic solid, third is metallic solid, and last one is covalent solid. Molecular solids are again classified depending on type of force of attraction between atoms. If it is polar, then that solid is called polar molecular solid. If bonding is non-polar, then it is called as a non-polar molecular solids. And last one, hydrogen bonded molecular solids. Both polar and non-polar molecular solids are soft in nature. They are bad conductor of electricity. Example of polar molecular solid is HCl crystal or HCl molecule. Example of non-polar molecular solid is hydrogen H2 or Cl2 gas. Hydrogen bonded molecular solids have hydrogen bond between them. This is additional bond which is formed by hydrogen of first molecule to the most electronegative atom like oxygen, nitrogen or others with another molecule. Due to this hydrogen bonding, as this one is additional bonding, hydrogen and oxygen both will acquire charges. Now, ionic solid, the constituent elements or constituent particles of ionic solids have ionic bond or ionic salts. Here, constituent elements or constituent particles are atoms of metallic element. Here, atoms of covalent solids. In ionic solid, as I say, melting point is very high because force of attraction between ions means cations and anions is very high. Now ionic solids, the bonding between cation and anion depends on three factors. First one is size of cation and anion. Second one, charge density or charge on cation and anion. And third one, ease of polarization of anion. Depending on these three factors, ionic bond or between ionic solids can be formed. Metallic solids are again metals. They are constituent particles in metallic solids are atoms of metals. Metallic solids are again hard and rigid. They have high melting point. They are good conductor of heat and electricity. As we know, metals are ductile. Metallic solids are also ductile and malleable. Covalent solids, example of ionic solid is NaCl. Example of metallic solid, you can take any metal sheet. Example of covalent solid is allotropes of carbon like diamond, graphite and fullerene. Now in this case, you know that graphite, generally covalent solids are non-bad conductor of electricity. But in this case, graphite is example of covalent solid, but it is a good conductor of electricity and it is due to sp2 hybridization of carbon atom. Due to sp2 hybridization of carbon atom, one electron of each carbon atom is free or mobile, which is responsible for charge carrier or conduction of electricity. Okay, these are classification of crystalline solids. Thank you.